Welcome to UGC's ePathshala lecture series on computer science. The paper is about visualization techniques, and today's module, which is module 32, we are going to look at how to embed the information using the focus plus context approach. The learning objectives of today's module are to introduce the concepts of focus plus context approach, to learn the issues that are available in focus plus context approach, to learn about the different ways of improving the focus plus context as such, and to learn certain examples in focus plus context visualization. Introduction to focus and context. The focus and context visualization is to enable the viewers to see the object of primary interest presented in full detail, while at the same time getting an overview or impression of all the surrounding information or the context information. The focus plus context also starts from three primaries. First, the user needs to know both the overview as well as the detailed information simultaneously. Second, the information needed in the overview may be different from that which is needed in the detail as such. Third, these two types of information can be combined within a single or dynamic display, much as in the case of a human vision. So what is focus? Focus is a black point on a white background, which is very precise and also holds our focus as such. The main focus should be on imaging every possible aspect to such an extent that the visualization feels that it is real. The focus helps us to show the selected region in a greater detail as such. What is change of focus? Change of focus is a rigid transformation of the hyperbolic plane as such, which is mapping the new plane back to the display. There are multiple transformations that are applicable, which is composite, which can be from composite into single transformation, and it also avoids loss of floating point precision as such. Computing the transformation for nodes with a display size with at least 1 pixel and bound on the redisplay computation. Visualization focus training as such. There are three types of techniques which helps us to improve the focus in the case of visualizations. So the three types of techniques which helps us to improve the focus are photograph, object, and the focus as such. They are helpful or good for controlling our focus as well as mindfulness. First one is the photograph. So we have taken a photograph and let us take some time to analyze it. We try to memorize every detail as we look at the photograph, and then we simply close your eyes and try to recreate it in your mind. So if it is possible for us to get almost all the information that is available in the photograph, it means that we have been highly focused on the photograph. If it is not possible for us to get the entire detail about the photograph, it means that we were out of focus when we were looking at the photograph as such. The next one is object. The ability to process the visualization information about appearances of the object and the senses terms of the pictorial properties. For example, it is a color and shape. We try to memorize the color and shape of the object as such, which helps us to remember the entire object. Next is what is focus plus context? Exactly. Visualization is to enable viewers to see the object of primary interest presented in full detail, while at the same time it gives an overview of the information of the surrounding information. The focus plus context system also allows the user to show the detailed information which is linked with the context by also having the possibility to focus on other information by interacting with the system as such. So here in this figure we can see we can have a look at the focused information as well as the overview information as such. So there are various focus plus context types as such that are present. Focus plus context actually starts from three primaries. First, the user needs to know both the overview as well as the detailed information. Second, the information needed in the overview may be different from the detail. and third, as we have already seen, that it can be combined within a single display as such. So this is your overview plus detail, zooming, and the focus plus context interface. So if you look at this figure, we can see there is a detailed view of the entire map that is shown here, whereas this entire part which is shown in the detail is also shown with respect to the context information in the lower right hand side corner, where we can see out of the entire map is being given, and the part that is being focused is also shown within a blue window as such. So this gives us a focus as well as the context information as such with respect to the map. So when we try to embed the focus and the context information, we try to combine the entire information within a single view as such. We try to elide, which is selectively filtering as well as aggregating the data. We try to filter out as well as aggregate the data inside a single window as such. We try to superimpose various layers using the local lens, and we try to apply distortion designs choices like region shape, which can be radial, rectilinear or complex, and we try to define the number of regions like one or many. We try to define the region extent, whether it is local or global extent, and we try to represent the interaction metaphor also. So this is a DOI tree which is represented here, wherein some items are being dynamically filtered out and some items are being dynamically aggregated together, and whereas some other items are shown in detail as such. So this is an example of a DOI tree. This is an example of a fisheye lens. So if you look at the fisheye lens, it shows the entire object using distort geometry basically. So in the case of distortion geometry, the shape gets distorted, where you have the radial display of the shape here in this case. The focus is going to be a single extent of focus. The extent is going to be a local extent, and the metaphor is going to be a draggable lens, wherein the lens can be dragged from one position to another. So this shows an example of a fisheye lens, and this also shows an example of the fisheye lens as such. So the part where the lens is being placed is a focused part, and the rest of the part is an overview of the context information as such. The next one is a stretch and the squish navigation technique, wherein we try to apply the distortion geometry where the shape is rectilinear in nature here, and the focus is not a single focus, and you have multiple foci as such. The impact as such is a global impact, and the metaphor that are applied are stretch and squish metaphors, and the borders are being fixed in this case. So it is possible for us to stretch and squish the data as such using this stretch and squish navigation technique. So what are the costs and benefits? The distortion costs and the benefits. The benefits are combining the focus and the context information in a single view as such. The costs are the length comparisons are impaired, that is network tree topology comparisons are unaffected, connection containment is seen. The effects of distortion are unclear if original structure is unfamiliar, and the object constancy or tracking may be impaired as such. So these are the costs that we are going to pay for this kind of benefit, that is showing the focus as well as a context information in a single window as such. So this is a static visual layering approach, wherein the foreground layers are shown as a rows here, which are being distinguished from major using the hue as well as the size, and you have high luminance contrast with respect to the background. The background regions of the layers, which are represented in desaturated colors for water, parks and land areas, and the user can selectively focus the attention. So here we have shown it in the black and white approach, where we can check that the luminance and the contrast is changing with the grayscale view as such. The next one is a hyperbolic tree approach, which also uses focus and context approach. So in this hyperbolic tree, we can see that there are various nodes that are being shown here. So if you go and click at one specific node, we can view the entire detail about that specific node that gets expanded, or the entire view of that specific node, the clear description about the specific node with all its children will be explained. So it is possible for us to get the entire context information along with the focused information using the hyperbolic tree approach. So the essentials of this are, it is possible for us to visualize the hierarchies as such using these kind of hyperbolic trees. The features are, there are more space to a part and still it maintains the context information. The schemes that are applied are layout on a hyperbolic plane, and this may be mapped onto a circular display. So the inspiration is a Azure woodcut, wherein in the case of the Azure woodcut, we can see that the size diminishes when we move outwards, and there is a huge growth in the number of components as we move outwards, and there is an uniform embedding which exponentially grows along with the structure. The space available to a node with all its children falls off continuously with the distance from the center in the case of an Azure woodcut. Some of the issues that we face when we try to put the focus as well as the context information on a single screen are, there are some problems with the layout as such, mapping and representation problems may occur, change of focus may occur, node information may change, preserving the orientation, there is a difficulty in preserving the orientation, and there are difficulty in animated transition issues in animated transitions as such. So now let us have a look at each and every issue in detail. The first issue is the layout. So if you look at the layout, the features are the circumference and area of the circle grow exponentially with respect to the radius. So the recursive algorithm laying out each node based on the local information, and there is divergence of parallel lines onto a hyperbolic plane as such. It is easy implementation and it is only required only once. The mechanism that we use in the layouts are, allocate a wedge of the hyperbolic plane to each node, place the children along an arc in the wedge as such, maintain the distance from itself as well as between the children, and recurs on each and every child, and each and every wedge retains the same angle as such. Let us look at the variations. In the case of non-uniform trees, we try to allocate larger wedge to sibling with more number of children, and this decreases variation in node separation. If we use less than 360 degrees, we try to put all children in one direction as such. The next issue that we come across in the case of focus plus context approaches, mapping and representing the data. In point-cost model or conformal mapping, we try to preserve the angle as well as we try to distort the lines into arcs. Whereas in Klint's model, we try to preserve the lines and we try to distort the angle as such. So we cannot have it in both the ways. So in such a case, point curve is being preferred. That is, the points near the edge get more screen area than in the Klint's model as such. If you look at the change of focus issue, it is a rigid transformation of the hyperbolic plane as such, mapping the new plane back to the display, and there are multiple transformations which compose into a single transformation and avoids the loss of floating point precision. Try to compute the transformation for nodes with the display size at least it is 1 pixel, and it is bound on redisplay computation. The next one is the node information. Some of the features of the node information are circles on the hyperbolic plane or circles on the Euclidean disk, and this decreases in size with the distance from the center as such. The mechanism that is being used is to display the node information based on the circular area available for the node as such. The next issue that we come across is preserving the orientation rotation. Translation on the hyperbolic plane causes the display to rotate, and this may lead to different view of a node when the node is being revisited. Notes further away from the line of translation rotate more. So to avoid this, most direct translation between points are specified and a rotation about the point is being moved as such. Some of the issues in animated transitions are tries to maintain object constancy and helps the user assimilate the changes across various views as such. So we try to generate using the nth root concept. The bottleneck here is the display performance. Since we are going to show each and every animated transition as such, it becomes very difficult to display the entire set of sequences. So we compromised for quick redisplay. We try to draw less of the fringes and draw lines rather than arcs, and we try to drop text during animation as such. Smooth transition from one state to another occurs, which is an alternative to jump cuts, and support for item tracking when the amount of change is being limited. One example for this animated transition is a multi-level matrix view. So in the multi-level matrix view, the scope of what is shown actually narrows down. The middle block stretches to fill up the entire space, and the additional structure appears within that. Other blocks squish down to increasingly aggregate the representation. So the example is shown here. This is an animated transition example. So if we look at the transition of the first block to the next block, we can see the block size increases and some of the blocks gets squashed, and that gets squashed into, and we can see finally we can get an entire representation of the animated transition as such. Selecting and highlighting a particular component. The selection is a basic operation for most interaction. So there are various design choices in that. How many selection types are there? There are click versus hovering selection type. Heavyweight can be lightweight. Primary versus secondary selection types, which is the semantics is also associated with it, which is a source or the target. In the case of highlighting, we try to change the visual encoding for the selection targets. For example, we try to change the color. The limitation here is the existing color coding is being hidden. Then there are various other channels like motion channel. We try to add explicit connection marks between various items. Next, changing the item visibility. We try to change the viewpoint as such. The changes which items are visible within the view. So the camera metaphor itself changes. We try to zoom in where there are different types of zooming like geometric zooming and semantic zooming. In the case of geometric zooming, it is familiar semantics. In the case of semantic zooming, we try to adapt object representation based on the available pixels. There is a dramatic change or more subtle ones basically. So the various movements of the camera like pan or translate, and we try to rotate the camera especially in a three-dimensional way. Next one is changing the item visibility. You try to change the item visibility as such. So you have constrained navigation. So you try to navigate often with animated transition, or you try to navigate often based on some kind of selection set. So here if you see, you have the geometric or the semantic where you try to zoom into the object, you try to translate it, and you have constraint approach. This is a semantic zooming example of semantic zooming. The visual encoding changes. Colored boxes are sparkled lines with simple line chart. The full chart consists of axes and tick marks as such. So this is an example of semantic zooming approach. In the case of focus plus context, we try to reduce the number of attributes as such. So reducing the number of attributes is in continuation to the camera metaphor. There we try to make a slice of the given object. Slicing an object is showing only the items, matching a specific value for the given attribute, which is actually slicing is done using a slicing plane. Then you have the axis aligned or the arbitrary alignment as such. The next one is a cut. The cut only shows the items on far side of the plane from the camera. The next one is a project. Project is changing the mathematics of the image creation. So you can have either orthographic projection or perspective projection, and there are various other projections like Mercator, cabinet, etc. So these are various examples of attribute reduction as such. So here in the case of slice, we can see how the entire object has been sliced, how the entire object has been cut, and it is being only a part of it is being shown here. Next one is projection of the entire data points onto the display plane. So this is a bird's eye maps. The encoding is, you have the same kind of encoding. The data set is a subset is being shared. The navigation is some kind of bidirectional linking. So the differences are the viewpoint and the size. This shows the overview as well as a detailed part as such. In the case of small multiples, none of the data is being shared, and there are different attributes for node colors. The same as that of the network layout, and the navigation is a shared navigation. So this is an example of small multiples. So here we can see the overview as well as a detailed part as such. The next example of the reorderable list. Here we try to investigate the power of multiple views as such. We try to push the limits on the view count as well as on the interaction complexity. We try to reorder the list. In the case of reorderable list, there is an easy lookup, and it is useful when linked to other encoding patterns as such. So this is an example of reorderable list, where we can see you have a parallel coordinate system, you have a scatter plot system. So it is possible for me to view the entire data set using various kind of reorderable list as such. Next one is partitioning into different views. So in this case of partitioning into different views, we need to look at how to divide the data point between the various views. Here, this encodes the association between the data points using some kind of spatial proximity, and the major implications for what the patterns are being visible, and the split is according to the attributes. There are various design choices. Some of the design choices are how many splits do we need to make. So this depends on whether it is one mark per region or it is for more complex structure within a region. We also need to look at the order in which the attributes are used to split and how many views are we going to show. In the case of views and glyphs, we need to look at the contiguous region in which the visually encoded data is shown on the display, which is a side-by-side view as such. In glyph, the objects with internal structure that arises from multiple marks are shown. There is no strict dividing line as such. So if you look at it, view is a big or a detailed view. In the case of glyph, it is small or iconic in nature. Some of the pros and cons of focus plus context approach are, if you look at the advantages of focus plus context approach, it is an easy blending between the focus as well as a context. It avoids distortion and hiding of certain amount of information. Scaling up to 10 times plus the space for text is faster. Some of the cons in this case may lead to cramping if each node has several children and not much accompanying information is available. So these are certain examples of the focus plus context approach. So if you look at the first example, we can see the entire information, the entire context information is also available, and if you move our cursor over each and every item, the detailed view of the focused information is being shown here. Similarly, in the second figure, if you see, you have the entire context, the full overview information with the detailed information of the focused object. So you have an overview as well as a detailed information as such. Similarly, in the third figure, if you see, you have the entire map as such. So if you want to look at a particular object, we can focus on to that particular object, and that alone is being shown as a context information in this window. So you have the overview as well as the context information, overview and the focused information in the same window as such. Similarly, in this figure, we can see that you have the entire view as such, and if you move, it is possible for us to look at each and every node in detail. Similarly, in this figure also, you have the overview as well as the focused information, wherein the entire overview information is shown here and the focused information is shown in detail as such. So if we look at the summary of this focused and context approach, we have looked at what is a focus and context approach. We have also looked at various types of focus and context, how to create this kind of overview and detailed information. We have also looked at what are the issues that we come across when we try to show the focus information as well as the context information on the same screen. And we have also looked at various examples of focused and context approaches which are useful in visualization to show the entire overview as well as the focused part in detail as such. Thank you.